Hello everyone, this is Jude, Assistant Professor from St.Joseph's College of Arts and Science, Cuddalore. Today we are going to discuss about fiber optic communication. And to start with, the fiber optic communication, that is a method of transmitting information, or we can say it's a signals, from one point to another point in terms of pulses, light pulses, through an optical fiber. Here the optical fiber refers to the medium in which it carries the pulses of signals in terms of light from one point to another point. The main advantage of this using of optical fiber transmission techniques is the loss of attenuation where compared to other transmission systems. The light that carries the signals, it is in the form of electromagnetic carrier wave, which is modulated to carry information. So it is modulated in such a way it carries the information in terms of signals in the form of light, and it is an electromagnetic carrier wave. And optical fiber is a dielectric waveguide that operates at optical frequencies. So the signal which has to be transferred from one point to another point is in such a way it should have a particular proper frequencies. So the optical fiber, the medium that carries, or the waveguide that carries information from the point of transmission to the destination point. So it is formally in the form of a cylindrical in shape, and the function that it confines the electromagnetic energy, which is in the form of light, within the surfaces, and guides the light in a particular direction without any loss or attenuation. So this principle, the basic principle in this propagation of light through a fiber is it can travel without any attenuation or less loss in the signals, and it can travel within the optical fiber. So the light ray should be incident in such a way so it can travel from one medium to another medium, and the important point to remember is the angle should be greater than the critical angle. As we know, the critical angle in general means after the critical angle the forum or the phenomenon has to be carry over. So the refractive indexes of the input light ray should be greater than the critical angle, and if it is achieved, if the critical angle is achieved, then the light gets totally internally reflected within the medium itself, which has the higher refractive index. So the basic principle is that when the angle, that is incident angle, is greater than the critical angle, the light should not get deviated or refracted, rather than it gets totally internally reflected inside the medium itself. So the refractive index is a very important parameter, and it is defined as the ratio of the velocity of light in vacuum to the velocity of light in the medium. In general, it discussed where we should always refer the refractive index with the velocity of light in vacuum, and the refractive index is also an important parameter of the light in which the propagation has to be carried out inside the fiber. Here you can see if a dielectric is placed on the either side of the interface. So let it be refractive index n1, which has the one side refractive index, and n2 be the refractive index on the other side. So which is lesser than n2, which is less than n1, the medium. Hence the refraction is in such a pathway, the index medium, at an angle of theta 2 to the normal theta 1. As we already discussed, it should be greater than the critical angle. As you can see from the diagram itself, it is Snell's law. So n1 of sine theta 1 equal to n2 sine theta 2. When it is greater, when the angle of incidence is greater, so the light ray or the light pulses should not get refracted, rather than gets inside the medium itself. So when the angle of refraction is 90 degree, and the reflected ray emerges parallel to the interface between the dielectrics, and when it is less than 90, and obviously when it is greater than the critical angle, it gets reflected. So this is important thing to be considered in the fiber optic communication. The conditions to achieve this total internal reflection, the basic principle is total internal reflection, and there are certain conditions to achieve this total internal reflection phenomenon, which is the base which ignites the total internal reflection phenomenon. The phenomenon of total internal reflection occurs at the surface between two dielectrics, and the refractive indexes is one which is a higher refractive index, and the other one should be lower refractive index. And the next one is the angle of incidence should exceeds the critical value. As we already discussed, the angle should be greater than the critical. There are different types of fibers. Step index fiber. In that step index fiber category, we have two more categories, which is single mode and multi mode. And in graded index fiber, we have multi mode. In step index fiber, the refractive index of the core is maximum and constant throughout the core. So the refractive index throughout the optical fiber is maximum in this step index fiber, and there is a step-by decrease of refractive index in the cladding. As we know, the optical fiber has two major classification inside it. One is core, another one is cladding, and the core is maximum throughout and the cladding decreases stepwise inside the step index fiber. And in multimode fiber, there is a difference of refractive indices of core and cladding. So refractive index of core is higher than the cladding, and the core has a larger diameter when comparing to cladding. So it is used for this type of step index fiber is used for short distance communication, and obviously it is the attenuation. And you can see the diagram of the graded index fiber, the core, cladding, and it is there. The core is in the center of the fiber axis, and the cladding is the overhead wrapper around it, and you can see the cross sectional view also. So it has the diameter, the core has the diameter of 2a, and the core contains the different types of refractive index when comparing to cladding, so it can propagate from one point to another point. And the differences between the refractive indices on the core or on cladding is very less. In step index single mode fiber, the core diameter is very small, it has low attenuation and very high bandwidth. So the important point to be noted is it has low attenuation and it has high bandwidth too. The numerical aperture is very low in the step index single mode fiber, and this type of fiber can be used for very long distance communications. Last one is the graded index fiber. The refractive index of the core varies parabolically, such that maximum at the core and minimum at the core cladding boundary. You can see in graded index fiber it varies in a parabolical path. The refractive index gets maximum at the core at the fiber axis, and it starts off decreasing in magnitude when it reaches the minimum at the core cladding boundary. You can see the general overview of the optical communication system, and you can see the input which is given to the modulator, and it is the modulator by using a carrier source electromagnetic wave which has a carrier wave for transmission, and it is coupled to the channel coupler. These are the segments of transmitter. So this is the optical fiber link, and in the receiver end the optical signals can be detected by the optical detector. The signals get amplified and the signal is sent for processing, and we can receive the output signal. So this is a basic diagram of the communication system. The primary objective of the optical fiber communication system is to transfer the signal containing information. In the optical fiber, by using the optical fiber, we can use the voice, data, or video from the source to the destination. This benefits optical fiber system is extremely important when comparing to the other communication system. It has very high advantages, such as immense bandwidth to utilize. So the bandwidth is very high. We can send more amount of data in terms of signals from one point to another point. So electrical isolation in the transmission medium. it cannot be affected. As a result, the attenuation is very low. The transmission loss, as we said, the transmission loss is very low. There is no deviation of light information from the transmitted end to receiving end. It is extremely small in size, and signal security is very high. Immune to interference on the crosstalk, there should not be any interference, since optical fiber is very high a covered medium. We can say there is no loss, so there is no chances of interference or crosstalk, and it is very less power consumption material, and wide scope of using it wide variety of system application. Due to variety of advantages, the optical fiber communication a wide range of applications. Public network include trunk networks, junction network, local access networks, submerged systems, and synchronous systems. So it can be used in a submerged systems. It can travel from a country to another country by laying these kinds of optical fiber cables. So transmission loss is very less, attenuation is very less, and next important thing is the cost of laying these optical fibers when comparing to other communication networks has been it's very low in cost. In the field of military applications, the security is extremely high, so we can use in military operations. It has the applications of all types of civil, consumer, industrial applications. It has industrial applications too. And as we know, in the field of computers, the center of research, right now we are using more number of optical fiber networks for communication in the field of research. So it has the wide variety of applications and more advantages, merits than any other communication systems. And in conclusion, even though there are some kind of negative in the communication optical fiber system, that is fragility, swirling, coupling, the expense to set up is somewhat high, but it is an unavoidable fact that the optical fiber has revolutionized the field of communication. Yes, of course we should admit it. Even though the setup cost is high, the maintenance and the other low loss, attenuation is low, these kinds of advantages given the important part in the optical fiber communication. Thank you.